Hey folks, welcome to the February community meeting. I'll be presenting Ramiro's slides. He got sick over the weekend, so I'm back. Yeah, let's jump right in. Let me present. Can folks see my slides?
Yep.
Yes.
All right, cool. Cool. So we have a light agenda today. We're going to be talking about the new ops and workloads as always. The transition to using the dtype functions, which is going to let us unlock various custom op workflows. And then the PI project or Pi project. I don't know, Max, what's the right way to pronounce that? But
I don't think we've settled, but Pi is good enough for now.
all right, Pi. All right, so let's jump right in. And just a reminder, so we have 3 events during the week. We have on Mondays we have our developer hour community meeting, and so that varies. The first Monday of the month is the community meeting, which is where you're at now, and then on the other Mondays we have this sort of agenda-less developer hour. Usually it's like technical design discussions and direction for the project. Then on Thursdays we have the op office hours. And that's more like lower level, just op debugging. So that can be useful if you're in the nitty gritty. Then we have our Discord real-time chat, which is quite active. And then our forum, which is less active. Cool, yeah, so in the last 2 months, we're covering 2 months here, we've had 100 commits by a bunch of different stakeholders. So that's awesome to keep seeing that diversity. And I see some new names here, so this is exciting. And cool, let's jump right into the updates. Anush, do you want to talk about the new workloads?
Yeah, the main thing that we've done since the last community update meeting is we're actually shipping Torch-MLIR to hundreds of customers, thousands. I mean, like there's probably 1,200 people on the Shark Discord, but downloads are more than that. But all of these users are using Torch-MLIR every day on Windows, and like using custom models, there's just a community around Stable Diffusion that's thriving with creating new mixes and new models and new styles, and I think it's great to see that it's actually Torch-MLIR is enabled by default. Previously we were shipping it, but we had pre-exported MLIR files that customers would be using, but now they just do it on the fly. So it's good to see the growth of Torch-MLIR like actually live and deployed. And thanks to the community for all the work. It's good to see it ship, and it does give us some good feedback loop on customers really hit. So like when they're compiling models, how long does it take? How much memory does it take? So things like that will start becoming high priority, going forward. Just because ops and the ability to like export is kind of like well baked in, but then there are other quality of life for end users that may start popping up, and we'll just address them as we get there. So that's that's what we're shipping. That's the second one. And then we also have a few large-scale training engagements that are using Torch-MLIR, it gives us a path to export to export the graph out, and then disassociate the algorithm from like the deployment. And so we're now validating that, and this is not just on GPU class hardware. It's training across custom clusters and in some cases very large clusters. So just as much as we've seen traction on the edge with Torch-MLIR, Torch-MLIR is now kind of growing into the training space, and obviously there are a lot of things that we have to figure out and sort out, but it's a good direction that we are headed in. And then the third one, Bloom 176 billion. We've had a large number of GPUs, like about 16 GPUs that we could deploy Bloom on the fly. Again, using Torch-MLIR and Shark at the back end, but Torch-MLIR is being used for very large models and sort of stable diffusion kind models in the edge and in the data center. Happy to answer any questions or any thoughts, just highlights of what we're working on with workloads. Cool.
Thanks, Anush. This is awesome. Does anybody have any questions for Anush?
What does the training time look like for 176 billion parameter Bloom model?
Oh, we right now the Bloom 176 was just done for inference across multiple GPUs, but the training is on the stable diffusion side. It's I think an order of like training from scratch. We're looking at like a few weeks and a large cluster, like 128 GPUs or more than 128 accelerators. Let's just call it accelerators, right? So in some cases GPUs, some cases it's the custom silicon, but it's an order of like a month or so. But obviously we don't run the whole thing every time, right? We try to get the like flush out the just make sure that the loss is converging, and then when we are ready, then we press the button to go. But right now we're just validating and flushing out that step for step. We see the same with PyTorch or the PyTorch plus deep speed or whatever the native format is today. We have a baseline of that, and then we have a baseline we create with the Torch-MLIR path, and then we just verify them at every step to make sure that we are getting exactly the same numbers. And then with Torch-MLIR, once we get to the MLIR side, then from MLIR we have some work in progress like CCL dialects for collective communications, and we interleave them, and then we kind of can kind of extract out the deployment part of like what kind of parallelism, how you're going to shard it, etc., from the core algorithm. So that's how we're splitting it up and validating. Cool. Any other thoughts or questions? Oh, no worries. Cool. Back to you, Sean.
Awesome. So new ops supporting all this. There's been a ton of forward progress as always on that. So let's talk about the transition to using dtype functions. So this is all part of the bigger custom ops design. So this will change somewhat in the PyTorch 2.0 story, but I don't see us completing like a full native migration to PyTorch 2.0, et cetera, et cetera, et cetera, probably till end of year this year, maybe even later. So for now, we've come up with a relatively straightforward extension of our current system, which basically allows you to plug in your own custom ops. So the main missing piece of that is that we have the shape functions already in a easily pluggable way, but we needed to do that for the dtype functions also. And this actually requires rewriting all of our existing dtype inference into the new system. So the this issue 1807 has a work list of all these different tasks, and we'd really appreciate your contributions to them. And some of them are actually quite straightforward. So please feel free to jump in and ask Ramiro on Discord if you have any questions, because he's leading that effort. Any questions on this? Arash?
Hi, Sean. Yeah, quick question. Is there going to be a transition to move all
I think your volume is really low.
Oh, is that better if I speak
Yeah.
up?
Yeah, much better. Yeah.
Yeah, sorry about that. I'm just asking, is there going to be an effort to move all the logic from refined types into these dtype functions for the current supported ops?
Yes, that's exactly what's being tracked in this issue 1807.
Got it. Thank you.
No problem. All right. So I think I see Max must have been somehow involved in these slides. So Max, why don't you take over?
Sure. The timing is going to be a little off because I guess I got to tell you the advanced slides. Anyway, so I don't know how many people on the call know me, recognize me, whatever. It doesn't really matter. But I've had like this white whale of a goal for quite a while, which is to compile PyTorch in a lightweight way such that A10 is not part of the final product. So there are a couple of PRs that are basically stale now, where I try to use PyTorch sanctioned methods to compile using lightweight dispatch, compile using some list of allowed whitelist ops and blah, blah. So they have in their build process these compile pads for like mobile deployment and blah, blah. And they tease at this idea that you could ditch a ton of the A10 kernels. And those PRs are stale because I basically figured out over the last summer that it's not possible. The way that all that works is through the linker. The linker, when they go through their linking phase, they ditch dead code, and that's what they mean by lightweight. There's no way to like reduce compile times and stuff like that and ditch unnecessary code. At least not in the compile process in the final package. Okay, anyway, so I've wanted this thing for quite a while simply because it's annoying to compile PyTorch, recompile PyTorch. Other people want this for various reasons. They don't want to like, hey, if you're deploying to Grok or if you're deploying to AMD devices, you don't really care about CUDA whatsoever. So you want, a lot of people want, some people want a lightweight way to support PyTorch models. And maybe there's like an organic way to get there. There's a grassroots way to get there where we essentially boil the ocean and people start porting all of their models to use some native Torch-MLIR front end. But that's not happening, you know, within the next year, maybe within the next 5 years. Maybe it will. Hopefully, we all have high hopes, right, for Torch-MLIR. But anyway, so we can go to the next slide. How we're going to get there supporting lightweight PyTorch models is we're going to reuse, abuse, recycle as much code as possible. So what that means is, and I'll get to that in 2 slides, is you want to use NN modules, essentially. You want to port / copy paste as much of PyTorch as you're allowed to, given licensing and given like the constraints of our project, in order to support existing models. Okay, so you can go to the next slide. So I've been hacking on this thing for, I think, like, I don't know, a month and a half. I think I started, like, the first commit is middle of December. And then slowly but surely it's been growing into something and like being proved out that this is feasible. So we have, you know, we're ready to release now, or kind of, you know, Ramiro asked me for some slides and I'm like, okay, cool. This is the right time. We've hit some milestones. So this used to be called SharkPy, and then Anush decided that he was going to, you know, he's got like a knack for naming schemes. We were into the Pi. I think the idea was there was to copy the scheme of AIT or something like that, or whatever the thing is called from Facebook. Anyway, it's not SharkPy. The shark was cute. The pie was cute. I was like, let's mate the two. I don't know. The link is down there. It's at nod-ai/pi. You can check it out. It's dangerous because it's got some rough edges because it's only a month old. You get it. Okay, let's go on to the next slide. Why would you even consider thinking about, you know, cloning it, trying it out from somebody who you don't recognize? You don't know who the hell I am. So on the left-hand side, we have essentially like a barometer, you know, my personal barometer for how well I'm doing as far as implementing this. So there are 785 in-tree end-to-end tests in Torch-MLIR. And currently Pi is passing 650 of them. The fails, you know, it's a little bit mysterious what the fail signatures are, what that means. What is IR fail? What is ambiguous lookup error fail? Whatever, it doesn't really matter. The point is that 650 out of 786, I don't know what percentage it is. It looks like 85% or something like that. So passing 85% of the tests, the way that, and we're running these in CI, obviously, right? And the way that we're running these in CI is a little bit cursed. So Pi depends on, as a, you know, pip requirements dependency, Torch-MLIR. And then when the tests run, I go snip, 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 and replace torch.nn.module with pi.nn.module at the import, like hacking the import lib, you know, the import mechanics in PyTorch. So you can trust that I'm actually not monkeying with any of the tests. I'm running the exact Torch-MLIR tests, and they're passing. A pass here means push it through Torch backend contract and lower it to lin-alg. So I'm not doing lit comparison, checking strings, blah, blah, until I get to lin-alg. And then I'm not doing race either. I'm doing one-to-one, like exact comparison, just using the standard library difflib. So the point here is I can push through 650 of the tests through Pi and push them all the way down to lin-alg, and I get exact match with what Torch-MLIR produces. And this is in principle without any dependency on PyTorch, right? So again, this goes through nn.module. It doesn't go, it goes through pi.nn.module. It does not go through torch.nn.module, because right now Torch-MLIR is being built with a dependency on PyTorch. Of course, I'm getting PyTorch during the pip requirements install. And on the next slide, I talk about, like, that's a to-do item to refactor it so that there's a way to build in CI in Torch-MLIR in the release, maybe, if people are happy with this. So that there are two versions, one that depends on PyTorch, one that doesn't depend on PyTorch. There's already a flag that says don't build Torch JIT importer, et cetera, et cetera. Okay, so that's the left-hand side. The right-hand side is kind of like not purely, but like speed up the progress, speed up the work, and get something going for this presentation. So these are 5 models. UNet actually isn't done, but these 4 scripts, and minimal is just like one convolution, but Inception, MobileNet, and ResNet push all the way through to lin-alg. I think actually MobileNet and ResNet are part of the end-to-end tests, but I'm skipping those for right now. But anyway, so basically Friday I was like, can I get a whole model through this thing, through pi.nn.module, blah, blah. And I was able to push through Inception, MobileNet, and ResNet pretty much without any problem. So does it work? Is this complete vaporware? It's not, I don't think it is. This probably lends credence to my personal biased feelings. Okay, let's go to the next slide. So a little bit about how this works. Like I've been saying repeatedly, the bulk of it is not copy pasting torch.nn module. The bulk of it is actually lining up the types. So the first step in getting this to work was, hey, right now the JIT op registry is used to generate generated ops.td, right? That's produced by running torch ODS gen. So the idea is to hotwire that and simultaneously, or whatever, not necessarily simultaneously, because I'm not doing it as a feature in Torch-MLIR, but I'm using that same code to generate Python wrappers around the Torch XGen Python bindings that MLIR already builds. So those Python bindings are not generated by Torch ODS Gen. Those Python bindings are generated during the compile stage of Torch-MLIR by MLIR table gen. Okay, so those bindings exist, and they're fine. They're honest. Like the infrastructure underneath them is actually very, very solid. Like I give a lot of kudos to Alex and Stella. I don't know if they're on the call, and whoever contributed to the the infrastructure of the Python binding. It's very good, right? I could wish for a little bit more extensibility, but it's good. The Python bindings themselves are a little bit, they're like kind of there's cognitive overload. You got to pass MLIR values. Some of them need result types in addition to the values that the operators operate on, stuff like this, right? So the idea is to generate nicer wrappers that more conveniently ergonomically speak to NN module. So there's this munging layer in between NN module and the MLIR generated Python bindings. And the hardest part of that was lining up the types, because I hope everybody on this call knows that PyTorch's type system is wacky beyond belief. maybe not the wackiest, but I don't know. It's a little wacky, and there are a lot of these corner cases, and a lot of the test fails that I was getting was because I had to like, oh, this thing is a float, but it's not a real float. It's a torch float, and this kind of stuff. It's kind of like diddly stuff. Okay, so that's the first part. The second part is, like I said, Torch and module, just copy pasting a lot of it and like snipping out kind of stuff that's irrelevant to the models. You know, they're like these API usage logging calls and whatever. So snip those out. Just leave pure NN module code that references other NN modules or references tensor APIs. And this is not critical, super critical. It kind of like determines how you would use Pi. But if you want to, essentially, if you want to build your MLIR module outside of the scope of a MLIR context, then you need something like an uninitialized parameter, right? If you're going to run the constructor for an NN module, and you're not within this, you're not in the context manager context of an MLIR context, then you're creating types and you're instantiating ops and whatever out of the scope of a context, and MLIR doesn't let you do that. Through the Python bindings, you can't do that. So you need something that is essentially like a lazy binded parameter. And actually, this wasn't like some brainchild of mine. In Tree and PyTorch, they have something like uninitialized parameter for a completely different use case. But it was like, aha, I could just recycle the concept. Again, good artists create, great artists steal, or something like that. Recycle the concept, and all of the parameters on the NN modules are no longer instantiated at construction time. They're delayed until you run the forward pass. So there's, like literally, I'm just using, again, I have ported NN module. So these hooks that I was going to say, I use a forward hook before you run the forward method to initialize the parameters. That's like a PyTorch thing. I ported it in parts, reused the site idea, recycled the idea. Before you do the forward pass, before you call forward, the parameters are initialized. Because at that point, the presumption is that you're in a MLIR context module. MLIR context, sorry. Okay, anyway, do the same thing for NN functional and torch.tensor. There's a little bit of kind of like questionable things done in torch tensor so that I can do is instance and kind of like type comparison again to line up the types. And sorry, I didn't mention this. You also have to do multi-dispatch, right? So one thing that PyTorch does for you that again is wacky, maybe not beyond belief, but wacky, is multiple dispatch, where different targets are called depending on the input types. So you have lots of adds. You have adds for floats. You have add for tensors. You have add for lists. I don't know. You have like 15 different implementations of add. And Python doesn't do multiple dispatch. So the way that I do multiple dispatch is, again, this is like the dirtiest thing. I don't know if there's a better solution without. I mean, there's no template parametric polymorphism in Python. So I don't even know if there's a better alternative. But essentially, register all the different add functions and then iterate through all the signatures and try every single one, try to bind to the signature. And if you succeed in binding, given your concrete types, then that's the right one. So that, in order to be able to do that, you need to do a kind of like is tensor an instance of the type annotation for tensor that add expects. So you have to like fiddle with things. Anyway, a little bit in the weeds. So that's everything. The one remaining thing that I've been kind of taking for granted and shouldn't be like a technical, might be like a complexity problem, but not a technical challenge, is how do you, like I said, how do you build Torch-MLIR without actually a dependence on PyTorch? And that's it. The last slide is stay tuned for more. There's probably like, I don't know, I could talk about bigger, better dreams, but I'll leave it at that for now. Yeah, so any questions? Happy to take questions.
So your goal here is to basically use the Python bindings for the Torch dialect to completely bypass Torch itself?
That's correct.
Okay, got it.
Yep.
So that when we ship to all the Shark users, we don't have a dependency on PyTorch when they want to. Right now, there's 137 meg binary that we have to ship to hundreds and thousands of users that we don't need that. And we would validate the models, obviously, that we support. So, it may not be general enough like PyTorch for, active usage for whatever else. But the models that we support, Bloom, Stable Diffusion, we'll just make sure it can go through this lightweight path and it supports the users that we need without having to have a dependency on Torch, Torch's dependency on Torch Vision, Torch Vision's dependency on Torch Triton, which can bring in and upload your home directory. We don't want to. So, longer term goal of like, we just want to target the Torch-MLIR, the backend contract with the lightweight front end. That's all.
Interesting. So this produces IR in the form of the backend contract directly, or does it produce it in the form of the raw import?
Whichever one you want. I mean, so whatever. Yeah, all three. I mean, so all three in the sense that I've been thinking and writing in tests in terms of linalg, but it'll produce raw. It'll produce Torch backend contract, and it'll produce linalg. I haven't been comparing other downstream dialects like those.
I mean, so are you using the existing Torch passes to go from the raw import to the backend contract?
Yes.
Okay.
Some of them I don't need. Like I don't need globalized objects, for example, globalized slots, because I just inject stuff into one forward method. So I don't use. I could be using the slots. That's honestly a more intelligent way to do the uninitialized param type thing, right? Which is I guess why you guys implemented that. But yeah, I use all the stock passes.
Interesting.
Glad to hear you say that.
No, I'm just thinking in terms of the longer term layering, because all those passes that you're relying on are passes that we eventually want to delete. And so, yeah, I'm just.
I mean, I'm as long as the MLIR generated bindings inject those ops into an MLIR module, I think whatever you do, I'm good. We're good.
Yeah, except that you don't, because there's actually a non-trivial step from going from the user's source code into the backend contract. And so you have to infer shapes, dtypes, and convert to value semantics.
Sure.
And that's a really, really, really hard problem.
So the shape inference, so I've considered at least the shape inference part where I could leverage the shape functions. Like I could do the shape inference at on the user side, right? When I instantiate the operator, I can refine the shape right there if I've tracked the shapes all the way through the construction process of the module.
Yeah,
because I'm passing in example args anyway, right? Like, and those have shapes.
Yeah. Well, I guess. Yeah, I guess I'm still having a hard time seeing where this lands in like a PyTorch 2.0 future. Because in like a PyTorch 2.0, Torch Torch Dynamo is going to give us, plus some other upstream utilities, is going to actually give us stuff directly in the backend contract. So is your plan here long term to bypass Torch Dynamo then?
We should mimicking exactly what Dynamo is. This is an alternator.
Interesting. Okay.
Whatever Dynamo stands on, alternator will stand on.
Okay, interesting. What do you mean by stand on?
Whatever the front end Dynamo generates, right, and it targets the backend contract, you can consider Pi to kind of mimic that contract, and it'll target that. It's just that Dynamo is a little more not flushed out right now, so we are targeting whatever exists today with the Torch dialect and the JIT path more robustly. So whenever Dynamo is flushed out, and however Dynamo, whatever the backend contract interface Dynamo resides on, Pi will reside on that too.
Yeah, but my concern is that if you're relying on the existing passes we have to lower into the backend contract.
I think that'll be for now, but Max, correct me. I think it's more like we'll just have to see how Dynamo evolves, and however the passes, in principle, you should think of Pi as like an alternate to Dynamo 2 in the future. For now, it's an alternate to the current NN module to, however we're coming down. So whatever it takes for us to make sure the backend contract can support Dynamo when it's fully fleshed out, Pi will kind of generate the same to target the backend contract.
So Anush is committing morally, right? He's committing to the goal morally and kind of like ideologically, right? You're asking this question of how are we going to pull this off? How do we foresee doing both shape refinement and enforcing value
and value semantics? Yeah.
So again, the little that I've thought about this, because this is really on the run, kind of like hoping for things to stick to the wall phase of the project. Shape and dtype refinement, like I noticed the dtype functions were being generated, and you spoke about it today, right? So there's going to be upstream, as far as Torch-MLIR goes, infrastructure for refining dtypes and shapes from.
No, that's also part of the code base that's planned to be deleted as well in the PyTorch 2.0 future.
So okay, that's yeah. Okay, so that, like I said, those were my thoughts. Hey, those functions exist. I'll be able to leverage them. As far as value semantics, I have not thought about that. I have not, because you're essentially re-implementing what are the view ops and what are the functional ops and what, like, stuff like this, right? Yeah, I don't have a great answer for you. I would say, kind of with all the hubris in the world, that what they're doing can't be that tough. In fact, I know that they have these affine functions, and that's how they do shape refinement and inductor, right? They have some kind of like SymPy-ish thing where they infer output shapes by operating on SymPy representations of input. So they have it, right? They push through input sizes through SymPy functions, stuff like this, which is not that hard. Like, I have my head around it, but of course, devil's in the details. So that might be a really medium-ish lift.
Yeah, I mean, I guess I just sort of encourage to make sure that you build on the upstream PyTorch infra that they're building for this, because yeah, I mean, anything that involves doing everything for every op is best left to them.
Yeah, I don't disagree that the goal is to obviate them, right? So these things are in direct tension.
Interesting.
Yeah. Anyway, like I said, still early phases.
Yeah, but I think the goal is, we don't want to add additional, like, at least at this stage, we're not asking for anything from Torch-MLIR to change for, building variations. That's fine. It's just the backing contract. That kind of stuff is fine, but we don't want to make anything specific for supporting Pi, right? The goal of Torch-MLIR is there's only one upstream, which is PyTorch.
Which is why that exposed metadata thing was at the C level, right? Like, keep things as agnostic as possible.
Yeah. So, but it'll be good to brainstorm and get your thoughts on how those things can intercept as it evolves, right? Like, Dynamo is still being fleshed out. So and we are doing this as an experimental thing. When it's not plan of record yet, right, for our customers. But when we ship terabytes of downloads, we don't want to ship a dependency on PyTorch in our exe. Right now, our exe has a PyTorch binary in there and everything that it wants, including Torch-Triton, which is all like, yeah, we don't want it.
Yeah, fascinating. Yeah, I'm sure that this is something that I'm sure we can improve that download cost equation.
Yeah, and I think the main thing is even like we can't push to audit wheel with the PyTorch dependency too, right? That we're hoping Dynamo will change that, but the same thing, like turning off the JIT exporter will give us an audit wheel passable PyPy version of Torch-MLIR too. It's just that we can't take the dependency on PyTorch because we're weak linking to PyTorch. So those are like infrastructural stuff that we'll sort out. But I think it's still experimental for us, and but I think it's at a point where we can show that, hey, 4 or 5 models are running. We wanted to share, get feedback. So we calibrate. We're not like off in the weeds doing our own thing, right? But if it gains more traction and we can actually ship to users, like if it works, Max's mandate is to get Stable Diffusion through this, right? And then immediately we'll switch Stable Diffusion to all the thousands of users that are downloading Shock will get Pi. They won't even know what it is. Like they're not using Pi. They're just taking a slider value from like 512 size to 768, But internally we have to call PyTorch, and then there's a warning about JIT tracing. There's a warning about something else because PyTorch is trying to look for Torch Vision libraries, blah, blah, blah. And that experience is just like, it's not a product, right? We want to like just like wrap all of that up. I mean, we'll always have the reference PyTorch path for new models. We're not trying to replace that, but from a deployability standpoint, we want to like just keep it to hundreds of .py files that are compiled and just shit.
Max, so to actually do the op capture, are you using Torch Dispatch then?
No.
How do you actually like go from seeing like a plus operator in the source code to like a torch.add.tensorOp?
So what the let's assume that the operands are tensors. Those operands are my tensors. They're pi.tensor, and that pi.tensor has addition overloaded, and that addition overload, the target of that is the wrapper for A10 add tensor or whatever it is.
Oh, I see. Okay.
Yeah.
Interesting.
It's like the follow your nose guide to implementing this kind of thing. There's nothing super clever about it. Like overload do essentially what PyTorch is doing, but use Torch-MLIR as a backend rather than A10 blah blah. So PyTorch has Torch arithmetic operators overloaded, and those overloads, those targets are A10 kernels. Do the same exact thing, but have it emit Torch-MLIR rather than actually run some kernel.
Interesting. Okay.
Yeah.
Cool. Yeah, that's really interesting. Yeah, I think we should talk about this more at the developer hour, maybe next week or something.
Sure. Cool.
Sounds good.
That's it for me.
All right, great. Well, let's move on. Our usual health checkup, that nobody has ever complained about anything, so I'm concluding that our project is the best, but if anybody wants to speak up and break our winning streak here,
Speak
please.
now or forever hold your peace.
Yes. All right, going once, going twice. All right, great. And actually, big thank you to Anush and I know Shay, who I don't think is on the call right now. All your great work on the CI and getting all of that working excellently. I think we're in a really, really good place now, thanks to all your hard work. So
And thanks to Sambhav too. He helped too, and also Vivek is on roll PyTorch duty. So if you magically see roll PyTorch rolling forward, Vivek is like pushing it along. So credit to both Sambhav and Vivek for keeping the process going. But I think we have a really good process. I'm trying to drop the Torch Vision dependency, except when we do it for tests, because some people were running into like, Torch Vision will cause if one of those wheels are missing, we go into a loop of like downloading Torch and versions of Torch and Torch Vision. We don't need it except for tests, so that's the only other thing that we have on the radar. And we hope to enable Python 3.11 because that's the latest stable version. So we want to track the latest stable version of PyTorch. Of Python. Sorry. I think hopefully in the next week or so we'll get that also, so you can use that.
awesome. Yeah, and thank you also to all the code owners of the different components for the reviews of all that. That's great. Yeah, so that is that. I think that is the end. Anybody have any other topics? Sambhav?
Hey, I did have one question going back to the timeline that you mentioned, Sean, about a full migration to 2.0. You said it would be possibly end of this year, maybe next year. So do we know if in this state, will PyTorch 2.0 continue to export ThoughtScript or support ThoughtScript? And if not, are we planning to just be pinned on like one of the 1.x releases?
So I would, okay, so I think in like the longest term future, I'm imagining we actually don't have any dependency on TorchScript, whatever, and that's not part of our system. In the somewhat nearer term, I think we'll still have some, probably the last use case that will require TorchScript is the ahead of time compilation use case for edge workloads. And that's one that I think some people are already using. And so that's that. But my understanding is that the PyTorch folks are working on using the same Torch Dynamo program capture technology to have a solution to that problem for us in the 1 to 2 year time frame. So we should be able to adopt that. Does that help answer your question?
Oh, so when you say full migration to 2.0, it doesn't necessarily mean that we would still be using ThoughtScript during this time. Like we would have migrated parts of the ingest to use Torch Dynamo, but there would be other parts that are pending.
Yeah,
Is
so
that
there
what you
would
mean?
be there would be at least the LTC path and the TorchScript path, but I think in those are not really part of the sort of forward-looking direction that it seems that PyTorch is going. Like they're kind of all in on Torch Dynamo, and so as far as program capture, and so I view us migrating to Torch Dynamo as our like primary thing, and the other TorchScript and LTC being more of a compatibility thing until all of our users can migrate onto
Got
the
it.
new stuff.
Got it. And this would happen even, within this year, right? Like within the next few quarters or so.
I don't think it's likely to happen in the next few quarters. That's just a random estimation on my part, though.
Yeah, I'd suggest, like Dynamo, there's a little bit of a marketing message and reality like mixed in, right? So we should just make sure like if it's ready and we have it, then we can give a good timeline on when that'll happen. But right now it's in flux. You can see like the breakages that we had for Dynamo, that most of the breakages are upstream Dynamo thing, right? So the marketing message of Dynamo is a little ahead of like reality of where it is. And I think
Yeah, that makes sense. I think that makes sense. The one thing that we weren't sure of is PyTorch committing to continue to have the ThoughtScript paths alive in 2.0 or not. Like
I think that's I don't think anyone has an answer for that here or even in the PyTorch team. So we can ask them for a clear answer, but I think long term, everything will become unified, and that's so for any good project, right? Like, yeah, everything will like work itself out, and there'll be one thing that rules them all. But reality is like it'll intercept that vision, and I think that's going to be true for this case too. So we'll see. Like in the end, you'll have to see how hard it gets pushed to being one or the other. But I think, yeah.
So they do seem to be making some good progress. So sort of our X fails that are, so we have a significant number of our E2E test X failed, but that number seems to be shrinking at a reasonably good pace. I just clicked into a few of these of our roll PyTorch integrations, and sort of slowly but surely all those upstream failures are going away. There seem to be, I think, I don't know, 1, 2, 3, 4, 5 remaining. But it was certainly, I think it was like 10 or 12 before. So they're working at a reasonably good pace there for like about 1 month of work, adjusting for holidays. So I expect in the next maybe month or two, which aligns, I think, with the PyTorch 2.0 release schedule. I think they said somewhere in March, if I'm not correct. They are likely to have these things burned down a bit more to the point that it's really just work for us at that point. And then it'll be a question of staffing for actually who in the community is going to implement those features. So I was actually working on those features, but due to some recent priority shifts, I'm not pushing that actively right now. But that could come back later. Ramiro could work on it. Any community member could work on it. But yeah, right now we're waiting on upstream PyTorch for basically for Dynamo to stabilize, essentially.
Okay, makes sense. Thank you.
All right, any other questions or comments? All right, well, thanks everyone for joining. I'm gonna call it here. And yeah, I'll see you next month and at the developer hours next week, possibly.
See you guys.
All right, bye.